Hello everyone, welcome back to the Trick Spot. So in today's video, we are going to learn about another oxidizing agent which is known as Collin's reagent. In my previous video, we have learned about oxidation and Jones reagent. Now this time we are going to learn about Collin's reagent. So how is Collin's reagent made? So Collin's reagent is nothing but chromium trioxide and pyridine. That means you have to take chromium trioxide and you have to add pyridine to it and you get the product which is nothing but Collin's reagent. So let us see the reaction of the same. So I'm taking CrO3, that is chromium trioxide. Then I'm adding 2 molecules of pyridine. So this is my pyridine molecule. Okay. I'm putting the bonds properly. So this is my pyridine, chromium trioxide with pyridine at 15 to 20 degrees Celsius. So at 15 to 20 degrees Celsius, what I'll get will be my Collin's reagent. So that is how I'll make the Collin's reagent first in this. So first I'll make my pyridine molecule as it was. So this is my pyridine molecule. Okay, I'll put the bonds also how it was properly. Bonds will not change over here. It's just that a lone pair of nitrogen will form a bond with the chromium atom. Okay, other than that everything will be almost same. So I'll write CrO3. So double bond O, single bond O and single bond O. So the ones with single bond O will have a negative charge. So nothing is as such changing in this. It's just that the pyridine molecule is getting attached to the chromium trioxide via a single bond between nitrogen and chromium. So the lone pair of nitrogen forms a bond with chromium. Okay. So this is my Collin's reagent. Okay. Now let us see the mechanism or how the reaction will take place. So it is similar to exactly similar to Jones reagent. In Jones reagent we had primary alcohols giving aldehydes. That means CH2OH will become CHO. So primary alcohols, that is whenever I have CH2OH, that will turn into CHO, which is nothing but my aldehyde. Okay, and then secondary alcohol will turn into ketone. So the action of the reagent is very similar, in fact totally same. That means nothing is changing as such. So secondary alcohol turning into ketone, that means CHOH will turn into C double bond O. It's just that this is a very selective oxidizing agent. Okay. So this is how it reacts. Now I've written some examples. So let us see the first example. Now in the first example I have CH2OH group attached. That means I have a primary alcohol. So that should give me an aldehyde, right? So that entire thing will remain as it is. Just that the CH2OH will turn into CHO. So C6H5, CH, double bond CH and CHO. So instead of CH2OH, I just have to write CHO. Okay. Now let us come to the second example. So actually the first and the second example is same. Just that in place of C6H5, I have written PHO here, which is nothing but the same, phenyl. Phenyl group means C6H5. So you just have to write the entire thing similar. So PH, CH, double bond C, and instead of CH2OH, we'll write CHO. So actually the first and the second reaction is same. Just that there I have mentioned C6H5, here I have mentioned pH for people who don't know what is pH. Okay, let us come to the third example. So we have CH2OH attached over here, and that means we will get aldehyde as our final product. So I'll make the benzene ring, I'll put the bonds as it was, and I'll just put CHO in place of CH2OH. Okay, other things will remain as it was. Okay, now let us come to the last example, which is phenol. Okay, and this is an example of CHOH type. That means this is a secondary alcohol type example. Okay, that means we will get a ketone over here. So instead of CHOH, what I'll do is I'll just put a double bond O. So instead of that OH, I'll put a double bond O. So the entire thing remains as it is, just that the double bond O changes. So these were some examples. Okay, it's just that you need to know how to form the reaction for chromium trioxide and pyridine. Okay, that is the Collin's reagent. Other than that, the action is exactly similar. So that's it for today. Thank you. I hope you like